or solution could be built, but also some of the use cases that us as ANS have come across within our customer base already, some of the questions that we're getting asked, and hopefully you'll find that of interest and of use this afternoon. A technical demonstration, just a very brief one about how we can get sensor data from a virtual sensor into the cloud, and then what we can do with that data once it's there. And also some examples of how we can visualize that data as well. So by way of introduction, my name is Darren Hogan. I'm the IoT Product Manager here at ANS. Alongside me is Mark Johnson, Head of IoT. Good afternoon. And without further ado, we'll just touch on the agenda. So Mark's going to talk through the ANS overview of where the IoT space is right now. The IoT overview and how we approach the challenge. We'll look at the demonstration, go through some technical aspects. We'll look at some case studies as well, and then finally we'll just touch on a concept called digital twins, which is representing a physical space within the digital world within Azure. We'll have time for some Q&A at the end. I believe there is a panel within the WebEx screen to allow you to ask questions, and we'll take those at the end if that's okay. Okay, without further ado, Mark, a digital approach.
Okay, thank you, Darren. Okay, so this is a little bit of an overview where we see the market and some concepts around IoT that you'll either know, or if you're just new to this, that you'll get a kind of good understanding from a market perspective where IoT sits from a digital services perspective. So this statement is around quite a bit, but it's worth reiterating. So the Internet of Things it's not a technology revolution, it's most certainly a business revolution, but it's just enabled by technology. And what we mean by that is the engagement strategy, very similar to most digital services, starts with business outcome. And we found that in the last 18 months that we've been looking at IoT, we have found that we are speaking to a lot of different people in the business area. So we find that speaking to people in estates, people in HR, in finance, that have got different perspective on what IoT can bring them. It doesn't just sit in the industrial space or smart buildings and things like that. So it's a very interesting landscape to speak about. But we've at ANS we've completely engaged in deploying IoT as part of our advanced services portfolio, which includes IoT, big data, and app dev. So most people will know that IoT is plastered all over the internet, it's plastered all over the news at the moment about connecting things. And the reason we are connecting things is we're after the data. And as you can see for some of the icons on here, there's some quite obscure type of icons that you'd think, well, where is IoT relevant in these spaces? Some you would say, yes, every day I'd understand why I would get data from that to understand, predictive maintenance, things like that. However, we're going to touch on one that is a little bit obscure, which kind of gives you an idea that IoT fits in most spaces. And whether you've seen this one before, but we're going to go around cows, which is an interesting concept, so we'll move into that. So these three farmers from Germany, they have a farm with around about 500 stock, and they have a massive challenge in when the cows come into heat is making sure that they can do the artificial insemination and do it to the best and most optimized way. So I think Fujitsu and Microsoft work together in producing a cloud model that will be able to predict when a cow is likely to be on heat and is ready for artificial insemination. So, but to identify a cow on heat, you need around about 20 to 30 minutes in the stables, and that's 4 to 5 times a day, which you can imagine that is not a good use of a farmer's time if you've got such a large stock. So these guys reached out from a technology perspective and how we would go out using technology to solve this particular business outcome. So some of the stats on that. So this is what the process of artificial insemination is. It lasts around about 12 to 18 hours, 21 days, and occurs from 10 o'clock at night to 8 o'clock in the morning, and is usually done by visual monitoring, which means a farmer has to be present and know the signs to be able to take this forward. Has a 70% inception rate, and there's only 55% probability of actually correctly identifying this stage. And the pregnancy rate is of 39%, which is fairly low when they're trying. They only got a small window of opportunity. So how can technology really help with this? So here you go. This cow's not on an ASBO. It's actually a Fitbit monitor for cows, for want of a better word. It's a pedometer. And what they found is that the number of steps, or the rate of steps that a cow makes, will allow them to identify when a cow goes into this ostrus state, so they can start to predict when it will be available for artificial insemination. So this is the stats that they took in the cloud, and as you can see there, is a 16-hour period to the actual optimum part of artificial insemination. But what they found while they were doing this and connecting all the patterns and building the business model and the data model is that although they got the optimal time for artificial insemination, if it was before the line or 4 hours before that line where optimum artificial insemination is, they could determine whether the sex of the actual calf, so female, and after that line was a male. So quite quickly, this helps farmers if they want to have a particular sex of a cow. They can certainly, making sure that artificial insemination will bring out that type of sex. So very, very interesting fact that they can do this, and they can only really do this in cloud with machine learning, some cognitive services as well in there. And what do the architecture look like? So basically, the sensor in the cow shed connected via wireless into a wireless router, which had a 3G card, which was connected into Azure. And then it used all the necessary features which Darren will go into when we go through the lab, on actually building the data model to predict or use the data in a most efficient manner to solve that outcome. So as you can see quite quickly there, the use case for this is, is a little bit off piece, but it shows the capability of IoT in this sense. So as you can see, with any new market, I mean, we know IoT is an emerging market, but we partner obviously with Gartner, leading market analysts, to understand what IoT looked like and what the hype around the IoT was in the marketplace as an emerging technology. I mean, they have been touting this probably the last 2 or 3 years as it's something that's it's on the cusp of becoming real. We know IoT generally is not a new concept. It means going back 50 years. However, with the emergence of cloud, we can now start to break out data sets from different sources and then start to do some really clever stuff around cognitive service and AI, and obviously machine learning. So we know that we're on the right journey from a business perspective. And of course, they have a strategic roadmap. So any enterprise customer moving into this space has to kind of organise this and have a strategy for IoT and ensure that it is managed appropriately. Gartner does recommend that you do create a centre of excellence, which allows different entities from the areas of the business to kind of collaborate on what that strategy should be, looking at all, different perspectives, and ensure that the IoT strategy is delivered horizontally across the business, ensuring that the business are completely involved and signed into the strategy, but also all the technology arms are geared up to deliver that as well. And obviously Gartner have a reference model. We don't use this reference model. We use, depending on which common data platform we will use that reference model, and we've actually added our own IP to that reference model. So we've got one for Azure and we've got one for AWS as well. But this pretty much gives you a good idea about what them layers look like in an IoT solution. So it looks quite complex. So as I kind of alluded to before, everything starts with a business outcome. Business outcomes, as far as we're concerned, are normally around, from a digitization perspective, around operational efficiency, workforce optimization, and customer experience. So there will be initiatives, certainly from a business perspective, to enhance them. So whether it's reducing operating costs, increasing operational efficiencies, obviously specific to a business, that stuff will be written down in the business strategy. Obviously increasing the productivity of staff, obviously quite important to get more out of your staff. Making sure the environment is in the right environment for your staff to be more productive. And then obviously around customer experience, making sure you're giving your customers the best experience from dealing with you as a customer. So business outcomes is always one that drives these initiatives. So these are probably the 4 components, although very high level. These are probably the 4 components that are involved in an end-to-end architecture. So things that have already been deployed in your infrastructure against things that will be deployed to actually gather the right data. So when you look at your business outcomes, what data is going to be important to you as a business, and how would we go and collect that data, and how would we collect the data? So what things do we need to deploy? What sensors, actuators, things like that you have to deploy in your environment, or do they already exist in a building management system, for instance, that we can get the data out? So once we've got the data in the format they want, we then need to back all that data from whatever place that data's been stored into a common data platform, so a cloud or an IoT platform. And that's when we start to use things such as analytics, machine learning, AI to be able to give us the proper insights into that business outcome and how we can make better decisions to drive them outcomes. So once we've got that and we've got the insights and we know what stuff we need to look at and change, we then build in that feedback loop using action. So if a certain condition threshold happens, I should be able to invoke an action that will go away proactively and change that particular environment to be either compliant, regulated, and I don't need a person to go and do that. So this is all about building automation and proactiveness into the infrastructure. So that's kind of a high-level view of what the Internet of Things looks like. So how do we break this stuff down? So the way that we do any digital service, whether it's IoT, whether it's big data, whether it's app dev, is we always start with a creative session. So it's very much about user stories. We speak to different departments within a business to get their perception or their views on what data or what they would like to see, but done in a format that's not technology related. So it might be the fact that I want to make sure when I come into why the toilet's always dirty or why the bin's always full. Although that is not a technology problem, it can be solved by technology. But these are the type of user stories that we get, and we've done this with a large building provider where we have 20 people around the room, and they all had a different perception about what they wanted to see in that particular building, from experience through to cleanliness and facilities management and things like that. So we always start there and start them user stories and get that vision built up. So once we've done that, we all do an assessment to find out what things are being deployed. So if it's building management, they've got lifts, they've got what mechanisms do they use to control them elements, but also what data can we retrieve from them elements as well, and how we extract that and get that data, which is important, or the data that we find is going to be important for this particular solution or outcome. How do we get the data? Once we've got the data, we understand the data, how we get that data out, and how we then transport that data from them sensors or them gateways into the cloud. So that's quite important. So connectivity is in 2 forms. You have connectivity from the sensor to the gateway, and you have then connectivity from the gateway then into the cloud. So from the sensor to the gateway, there's a load of new protocols on some are new, some are relatively been in fruition for quite a bit. So you've got LoRaWAN, which is basically a low power wireless access. You've got Zigbee, which is anybody that's got a Hive at home uses Zigbee as a protocol to connect your temperature gauges to your gateway that sits plugged into your home broadband. You've got Bluetooth, which is well known. You've got 6LoWPAN, which uses IPv6. So we've seen with the mobility of that market, IPv6 sits as an entity now that is pretty important from an addressing perspective. So they're the type of things. So also, whether you connect from a backhaul perspective, whether we use cellular connectivity, 2, 3, 4G, NB-IoT, even 5G as and when it comes available. So all these connectivity mediums are applicable. But also it depends on the integrity and regulation and compliance of connectivity for an IoT solution. If that is real important data that you need to transit to the cloud, then we'll be able to create a WAN with an overlay with increased encryption to make sure that this data is secure in transit. So the connectivity is as important as most things there. Then when we start to get into the data platform, that's when we start to look at how we manage the messages to and from the sensors and the gateways, how we ingest that into a database, looking at the format that is likely to be consumed by an application, and whether we need the data to be read in real time, or whether we can just do cold storage and use that for machine learning at a later date. And once we've got the data in, then we can start to run the analytical programs, so machine learning labs, business and data models will be generated, what integrations do we need, and if we've got business intelligence, what insights can we drive from analytics and building that model to represent the right outcome. And obviously that will then be ingested into an app dev environment, so whether that's a web app, whether it's a BI portal, or it could be a line of business application, ERP, CRM for instance. So that's where that's kind of broken down. This is a high-level view of the architecture that we've got at A&S. So we've built this over the last 18 months. The good thing about this is we've had a lot of the elements for a good period of time. So if you look at the way that we've broken down the things, data, insights and actions, is the underlying infrastructure from a technology perspective, we have got the majority of them components already in-house. We're already delivering services from them, so we're already a cloud services provider. We've got an app dev environment and resource, and we've also got our own WAN, and we can provide probably 80% of that end-to-end piece. What we have done in the last 12 months is we've partnered with some large solution aggregators, so some global distributors. So we work with a company called Arrow and a company called Tech Data. They've been partners for years, and they have an IoT arm, and they manage a lot of manufacturers' sensor embedded systems, but they also got the capability to build solutions specific on a customer requirement. So for instance, we've done this with a customer that wanted to have a particular sensor with certain data points within that sensor built specifically for them. And we did that for a large university in London, and they bespokely built all the sensors, had an enclosure, the connectivity was all specific to the gateway they wanted to provide. So that is the capability we can go to from that. That's not something we do, but then we have the capability of making sure that the gateway is also either Azure or AWS certified, that it will connect straight back into Azure and provide that security required from an encryption perspective from whatever sensor or from whatever gateway back into the cloud. So that's the type of stuff that we've done. So we can purpose build stuff, or we can get stuff off the shelf that's already been prototyped and proved. Then you look at our connectivity, you can see all the providers that we've partnered with. So all the leading SPs in the UK, we have got a NNI with, which is basically a network connection, so we can provide any WAN service you require, and we're also a mobile virtual network operator, so we use wireless logic for that type of, which uses the best connectivity, likely the best service for a SIM, multiple SIMs, so O2, EE, Vodafone, it will use the best service in that area, so that's what we tend to use to bring back all traffic. And when customers want to have this segregated from their corporate infrastructure, then we can certainly provide an encrypted and secure service separate to that corporate environment. Then obviously we ingested there all the kind of components that are sat within the IoT platform, which Dan will go into more detail when he shows you in the demo. And then obviously we integrate that into Power BI. There's some other line of business applications and that can be integrated into, but we do pretty much 80% of that end to end. And obviously we ensure that security and management is built in from the start. So whenever we engage now with customers, security is one of the first conversations that we have with customers to make sure that it is built in from the start. Because if we start to retrofit towards the end of a project, it ends up being twice as expensive and actually is never fit for purpose. So that's a discussion around that. That's a little bit more on the IoT security in depth. We also know that Microsoft have brought out a new service around Azure Sphere, where they've now built security into the MCU, so a microcontroller that will control sensors within a certain environment. We can now get hardware-based security, certificate-based security in the hardware, and a lot of the larger manufacturer Intels now are building this into the chips. So basically, as soon as that gets deployed, we can then run an Azure Sphere service within Azure, providing the certificate, the life cycle management, and the updates back into the hardware of the actual sensor. But also we look at the encryption of the connectivity, then we look at the data at rest and making sure everything is encrypted and secure within the cloud as well. So the approach. we always start with assessment. It's the only way we feel. We've approached this the last 18 months in several different ways, and this is probably the proven approach which we have agreed is the best way to do this. Because it's a digital service, not necessarily an assessment, we do a plan and design engagement with the customers because it's more digital orientated. And that, it involves a free discovery, it involves validation of a lot of the data sources that are required to fulfill the business outcome. I mean, is that data, is it valid? Is it in the right format? Can we actually get access to it? Can we get it out of the systems that it's currently in? So there's a lot of moving parts in IoT, as anybody that's looked at this will know. So it needs a proper approach from an assessment perspective. And we produce off the back of that assessment with a high-level design, and there's some prototyping in there as well. The user stories that we spoke about briefly are all done in that assessment. And then the business case can also be produced in looking at what the ROI and TCO is likely to be from that particular engagement from a business outcomes perspective. Once that's been agreed, we'll move that into proof of concept, and we'll run that through probably a short period of time at a fixed price. And what happens then is that it is done in 3 months. It's not done in 12 months, 18 months. It's qualifying the assessment and the findings in the business case. And once everything's happy, then we move into deployment, and we're happy to transition any customer into that deployment and provide a managed deployment and service as and when that's being deployed. Because what will happen is, which is why we select the common data platform requirement, is that any additional initiative that sits off the back of this, because this might be just one value chain, we may look at 3 or 4 or 5 different value chains later down the road. If you look at a smart city, for instance, won't just look at, parking, it will look at parking, it may look at lighting, it might look at waste management, it might look at building management. All that stuff are different initiatives that need to be integrated into one platform. So you can see quite clearly how complex this kind of gets. So you need to look at the integration points, which is why the assessment is always kind of important. This is the kind of, I've gone through that on the previous one, but this is kind of what the timeline is, how we engage. Evangelism session is that session I said we do a line of business, getting everybody sat around the table, looking at all their perceptions and what they want to get out of a particular solution if they would do it, what we'd like to see. Pre-discovery is how we would size it, looking at all the value chains we need to work on with the customer. That goes into that P&D session we mentioned before. And out of the back of that, you'll get a service and solutions architecture, so a HL, a high-level design, which will also dictate what's going to happen in a proof of concept or a pilot. And then once that's been agreed, we then move into that build. Once we get into the build, that's when we start to engage our data scientists to start to get more understanding about the business outcomes, changing the data models to reflect what the business outcomes try to drive. Then obviously we optimize that over a period of time to make sure that you get the right outcomes and they're visualized right, and also start to move into actions as well. What insights drive certain behaviors, what behaviors can be driven from that feedback loop and feeding actions back into the systems, which is why the two-way integration is always massively important. And then obviously you onboard that into operations as and when it's ready to be supported. So this is who we work with, quite a few. Citiverb there, we were involved in the inception of that, providing all the lower WAN connectivity. Some of the hospitals and the council are looking at some big data initiatives at the moment for very digitised. We're now looking at waste management, parking is another big thing for the City Council. And we've got a couple of use cases at the end after Dan's and his demo, which will show you some of the stuff that we've worked with in that area. So I think we're now into the demo, so I'll hand over to Darren.
Perfect. Thanks, Mark. Lots to think about there. If anyone would like an ice cream, we've got that covered as well. So we've got ice cream van screaming outside the window, but we'll carry on regardless. So what we thought would bring this to life would be a demonstration of the technology to try and understand in a little bit more detail what's happening from a sensor perspective. So we thought we'd set this up and go through this today. So this is the small architecture that we're going to go through today. So on the left-hand side, we've got a virtual sensor. So we'll see that this is a piece of code that's running on my laptop here in the office that's sending telemetry data into the cloud, so over the internet and into IoT Hub, Microsoft's key application for ingestion of telemetry data. And we use IoT Hub because it's a massively scalable function, so it's capable of handling tens of millions of messages and hundreds of thousands of sensors. It is really scalable and performs a fantastic function. it's the ingress method from the Azure perspective. We then take the data from IoT Hub and push that into a function called Stream Analytics. So Stream Analytics is basically a function that allows us to run queries, SQL-like queries on data in real time. So things like adds, joins, selects, you know, and you know, taking data and coupling it and enriching it with potentially static data stores. That can all be done within Stream Analytics. And then taking that data and then pushing that in this demonstration into a Power BI dashboard. We'll take a look at a couple of examples of how we can use Microsoft Power BI to be able to visualize data in a real-time fashion, but also in a static dashboard with a manual refresh. And then also we'll take a look at a web application as well from a visualization perspective. So I'll just pop out of this and then we will get up the Azure dashboard. So from an Azure perspective, we have a number of services running or will be running throughout this demonstration. This is the Azure portal. We've got a Stream Analytics job that we'll fire up. We've got an app service, IoT Hub, which we remember is the ingestion mechanism for events, and various other bits and pieces that help us route the information through IoT Hub securely. So what we'll do is we will set our virtual sensor running. So hopefully there you can see telemetry data being sent by the virtual sensor and into IoT Hub. So what we can do is that I've got another application here that's talking to IoT Hub's back end, and we can see the device to cloud messages being responded to in real time. So I'll just fire that up. And so there we can see the telemetry that's being received by the Azure backend. So we can see the received messages, we can see the data being sent, and that IoT Hub is receiving those messages. So that's all well and good. What we'll do is we'll just go into another virtual sensor, and we'll start that working. So we'll again get some data being sent. We will then go into back-end application. So I just want to show you here the command and control capabilities from within IoT Hub. So because it's an ingestion mechanism, but also has capabilities to speak directly to sensors, we can send information to a sensor. So we can ask the sensor to only listen to certain aspects, so only send us temperature information if we're just interested in temperature information, or just humidity. We can also tell it to restrict the amount of data that's being sent through. So what we'll do here is we'll instruct the sensor to only send us data every 10 seconds. Oops, that's the wrong one. Give me a second. There we go. So we've sent a telemetry interval message to the sensor. So what we've instructed it to do is to, just at the bottom here, we can see telemetry interval set 10. So send us information every 10 seconds rather than sending information every second. And we can see here at the top that message has been received, direct method payload received, set telemetry interval sent and received successfully. So now we're only sending data every 10 seconds. So again, just an example of how we can use IoT Hub to control the behavior of the sensor. So what we'll do is we'll go into the first sensor that we started working, get the data running again. Okay, so within IoT Hub, we are now seeing data coming in. So the device to cloud messages starting to ramp up. So we know that IoT Hub is receiving those messages. So if you remember back in the diagram, we're now going to take the data from IoT Hub and push it into something called Stream Analytics. So let's take our Stream Analytics job. So as we talked about earlier, Stream Analytics is a method of being able to apply queries to data in real time. So for example, taking an input from a specific function and then performing a query function on that data and then sending it as an output. So in this very small example, what we're doing is we're taking an input, which in this case is on the right-hand side from IoT Hub. It's a messaging endpoint, and there is some shared access policy information there with, and a consumer group, so a consumer group for the information. So we're consuming that information from IoT Hub, and then in terms of an output, we're sending that to Power BI. So I've already set up a Power BI workspace, and this information will be sent to Power BI in the form of a data set. So we'll see the data sit at rest within Power BI so that we can use that to create a graph, a real-time graph. So the first thing that we need to do is to start the job. So we will start the job now. So that'll take about a minute to fire up. So in the meantime, what we'll do is we'll zoom across to Power BI. So this is my workspace. And we can see here device telemetry test, which is the data set that we've instructed IoT Hub to create. So this has already been pre-created because we've run this demonstration previously. But what we can see here is the ability to be able to create a report. So within Power BI, the ability to be able to create a report of that data. So for those of you who are unfamiliar with Power BI, it's a business intelligence tool that allows us to analyze data, either static data sets or data sets from streaming sources, such as we're using right now, SQL databases. There are a number of connectors available for Power BI now to integrate with third-party systems. But today what we'll do is we'll just create a very easy line graph to visualize the data. So this is our line graph right here. On the right-hand side, we can see some of the fields that have been presented to us from IoT Hub. So we've got an event in queue time series here, a processed time event here, and then we've got humidity and temperature, which obviously are the aspects that we're interested in. So I'll just double check back with the Stream Analytics job to make sure that it's started. Just take a few seconds to get going. It is running. So we should be able to see some data. So let's go ahead and create our graph. So for an axis, we need to have a time. So let's use a processed time for that. And for the values, obviously, we're interested in humidity and we're interested in temperature. Now, there's some funny numbers there. What we need to do is just make sure that we're just looking at the most recent data in the last one day. So we can see here right at the end that we're starting to get that data coming through. So humidity and temperatures being shown just here. In order to refresh that information, we have to hit refresh. So again, we can see that the data's been refreshed. This is me pausing the job and then starting it again later today. But in order to see the data in real time, we need something a little bit more real time than the thing that we're seeing right now. So in order to see real time information, what we need to do, let's just go to workspaces. We'll get rid of that. We'll create a brand new dashboard. Let's call it device telemetry. I'll get rid of that. So we will add a type, and at the right-hand side here, we can see that we've got various custom streaming data as an option for real-time data. So let's select that. And we can see here the data sets that are available. Device telemetry test, that was the data set that Streaming Analytics created for us. So we'll use that. And then this visualization type is how we visualize the data. So we want to use a line chart. We'll add a time series. So let's use process time for that. And then for the values, obviously, we're interested in temperature and humidity. And apply that. And then hopefully there you can see in real time now we're starting to get that streaming data through. So within a few clicks, we can visualize the data through Power BI, and we can get a real insight into what's happening in real time. We could take that one stage further. Again, custom streaming data, let's just use another visual, a very simple card, and we'll add, for argument's sake, humidity. And apply that, and then we can see the humidity changing in real time, and then we can see the humidity and temperature on the line graph changing in real time as well. So a couple of aspects there of how we can visualize data within Power BI in real time, but not everybody obviously has Power BI or access to Power BI. So let's take a look at another way of visualizing the data, which would be within a web app. So we have a web application pre-installed here. So one of the beauties of using Azure for IoT is that you can use your own applications, develop your own applications to integrate with data sources. That's one of the great things about the platform. And here we've just incorporated a simple web application which will just start now to interrogate the data that's being sent from the Stream Analytics job. So again, that'll take a few seconds, but so this is really useful when we're trying to visualize data and we don't have access to a BI tool. It's entirely possible to be able to see that data simply through a web browser. So we'll just wait for this web application to load up, which should be a few seconds, and then hopefully we'll see the web application here in real time. Let's take a quick look at view of the dashboard. We can see monitoring now. We can see our Stream Analytics job is starting to take events through. And then hopefully there we can see temperature and humidity in real time through a web app. So, you know, the ability to be able to view that data not within a strict BI platform is obviously, you know, very, very powerful. So there's a couple of examples there of seeing real-time data streaming through. And we took a look at Power BI from a presentation perspective. But taking this one stage further, there are a number of things that you can do with Power BI over and above streaming real data. So we've got a couple of examples here. So this is an analysis of the data that we took from our booking system. So we use Office 365, and by interrogating the booking information, we were able to get a really good insight of how one of our meeting rooms was being used. So this is the Victoria meeting room, which is where we're sat for this webinar this afternoon. And this is a panel that shows the use of this particular room over the last 12 months. At the top right here, we can see the teams that have booked out this particular room. Bottom right, we can see the number of hours over a year that particular team has booked this room out. But on the left-hand side at the bottom here, what we have is it's a word square that's comprised of the subject of the actual booking in the system. So we can see that, for example, if we look at business assurance, we get a sentiment of why that particular meeting room is being used. So catch-up audit, quality audit, that kind of thing, all things that you associated with the BA team. You know, people, operations, bid management, sales, etc., etc., etc. So we can delve into not only how many hours this meeting room's been used, but also what the reason is. But if we take that one stage further, we can see in the word square here that we have one-to-one. So 31 occurrences of a one-to-one meeting happened in this room, which is a 4-person meeting room. So if we click on one-to-one, we get insight into not only who's booked the meeting room for a one-to-one, but how many hours. Well, we can see in December, 57 hours worth of meetings were one-to-ones, which is all well and good. But if this was a larger occupancy meeting room, if this was a boardroom of 12 people, 15 people, 20 people occupancy, and it's being used for one-to-ones, then that in itself would be a good business case to say, right, well, we need to move our one-to-ones, or we need to create one-to-one spaces, or we need to rethink how we're using this room, because that would indicate that it's not the best and most optimum and efficient use of that particular room. So that's another example of how data really can drive decision-making within a business, from something as simple as how a meeting room is being used. And we're talking to customers that have exactly the same challenges, and some interesting observations there around how we can use data like this to be able to make the best use of space. And then the final one really is something that we've developed internally that we're looking to looking to roll out, hopefully, which is kind of like a front of desk or front of house screen. So this is taking a number of different data sources and presenting them in a single pane of glass. So what we have here, if you take you through the board, is at the top left we have current external temperature, 15 degrees, which is an external weather feed. We then have a floor plan of the office, so we can see which areas, so dark purple is occupied, light purple is available, and these are some hot desks here as well that we can track and monitor the use of. We have temperature readings from different areas of the physical building and a date and timestamp when this was last taken. And then, you know, a quiet zone aspect here, which is around noise levels. So if, for example, a colleague wants to work in a particularly quiet area, you know, obviously this is an open plan area, not unlike other offices up and down the country, then we can provide advice and guidance on where the quietest area of the building is. So we're not relying on somebody looking at a dashboard. We're actually presenting that information in a very easy to read and consume fashion. This is the current car parking spaces available, so we have a camera that we have pointing at the rear car park, which we'll go through in a short time. This is the current hot desk occupancy, number of hot desks free versus available, and then finally a snapshot of last November of how many meeting rooms are being used and how many days those meeting rooms are being used. So basically a heat map for meeting rooms. So just a couple of examples there of working with a BI and an analytics tool in a little bit more detail to get further understanding of how spaces particularly are being used in these examples. So hopefully that provides a bit of context and colour for you. So I will go back to the slide deck at this point. I think we're good to go. So use cases.
Okay.
I think Mark's going to cover this off for us.
So we have a couple of use cases, and some that we're going to go into a little bit of depth with, and some that we're just going to scoot over. We'll give you an idea about what type of use cases we're seeing in the marketplace at the moment. So this is a case study for a large building provider, owner and managed office provider in the northwest, so 120 buildings in north of England. And we've been specifically working with these guys, got some massive business objective targets of reducing operating costs by, I think it's up to something like 30%. And really, they are looking at their energy and sustainable energy landscape. So that is how they manage the fees coming in, because this company also is a managed energy provider. So they provide energy to all their tenants, some other businesses. So they have to provide analytics to tenants and customers. So ensuring that they have the best environment to be able to deliver that, and also be able to provide other services that are over and above the normal. This is what you get billed, but looking at usage, looking at time of day, looking at that type of information they want to provide to tenants. And also removing the legacy of taking manual readings from meters such as gas, electric, water, and using technology to be able to do that dynamically, and then just reconciling that type of data at the end of the month. At the moment, I think 75% of their staff are doing manual reading, so there's definitely an appetite to start moving this type of solution to digital into the cloud. So the first thing that we worked with, which is something that Darren works on quite closely with the company, is on a smart building. So start looking at space utilization, looking at meeting room occupancy, looking at well-being, looking at temperature, humidity, looking at CO2, looking at VOC, light, noise in their buildings. So there are 4 main buildings that we're working on in a proof of concept. Is be able to provide and basically provide the insights into them particular buildings on occupancy. Massive problem for meeting rooms, massive problem for areas being cold and not being utilised due to meeting rooms that are cold, dark, so they don't tend to get used. So that space is not being utilised or could be resold on, or from a building operator. But if you're looking at any company looking to reutilise space to make it more usable rather than buying additional space is certainly in demand at the moment. We find this very much in universities when they're starting to build additional large complexes because they don't understand how their current environment is being utilised from a utilisation perspective, but also from a footfall perspective. So that was big. So working quite close with these guys to make sure that we can provide that solution that gives them the visualisation and then building that into the data. That first stream will also fit into the second stream. So the second stream really is building a common data platform that can ingest data from the wellness service, which is the IoT Smart Building deployment. It can take it from the current billing system, the amalgamation of probably about 7 or 8 different BMS systems that they've got in different buildings, so okay, all got different data types, from connection into the grid, so they can start doing time of day billing, because obviously you pay for demand, but also looking at when is the best time to go into a sustainable energy source rather than using the grid, so they can keep the price down and also provide more best savings to their clients and obviously retain customers going forward. So how have ANS been involved in this? So we provide the end-to-end managed service for them. We've deployed the sensors in cooperation with them guys. We built the cloud platform, and we built the BI engine for them to start to get the insights. So that's where we are at the moment, and we'll provide a managed service to make sure all that stuff, all the modelling is being done by ANS with our skill sets. So some of the services that we're using in Azure Digital Twin, which is what Dan touched on previously, only briefly. We're using that. We're using event hubs, which allows us to route certain events to certain places within the cloud. Stream analytics allows us then to look at how we stream real-time data or cold analytics that we may use for machine learning at a later date. Cosmos DB allows us to do unstructured data in a format that can be consumed by an application, depending on how that's going to be built. Logic Apps is the interface between the cloud and other entities such as line of business applications and things like that. And then obviously functions are a bit of code that allows us to customize how that's being built. And then Power BI is obviously the business intelligence portal that Darren showed you in the demo. But also what we found is that this is all very good from an IT or technology perspective, but how do consumers want to consume these services? Whether you're a tenant, whether you're a member of staff, whether you're a visitor, whether you're an owner of that particular building, you want to see different things, and an application is the best way to interface into this service. And we're looking to use bot services, we're looking to use all these different new age, agile services within Azure to be able to provide improved services and experiences for all them entities that we just mentioned there. Even cognitive services from a vision perspective. I think we touched on the vision piece in one of the other user case later on in the webinar. So that's where we did in that case. So that's been a very interesting thing. And most people, I know this is a commercial type of book, most people have buildings, and there is significant savings to be made in buildings. It might not be IT that manages this, but certainly within your business where you've got a lot of rooms that need to be, space utilisation, or even managing the energy of buildings, managing lifts, managing lighting, managing the actual energy in that particular building is of utmost importance, that you can start to drive some operating cost reductions quite easily just by being able to connect half them endpoints into the cloud. So that's where we are with that case study. So also with this case study, we talked briefly about when I did the high level architecture. On the left hand side, we engage with 2 partners from a direct perspective. One is Yanzi, so this is Yanzi Networks. They provide the sensors, they provide the gateways, they provide a maintenance service, so they will look at the life cycle of the sensor and the gateway, providing firmware updates, security updates, ensuring that's all going to be compliant and it's regulated, and it can be provided the necessary service and always will be up for our clients. So we've chosen them. They're very closely integrated in with Microsoft, which is why we've used them, been recommended to use them from them. And then what they do is they provide us then with a WebSocket or an API into their services that we ingest into Azure via IoT Hub or Azure Digital Twins, which we'll go into later on. So that provides us with all the data that we want to do. But we're seeing a lot of sensor manufacturers, actuator manufacturers now looking at providing a service and going down this service revenue marketplace, providing extra value in what they do rather than just commodity electronics. That's what we're seeing. And this is just another one where these sensors are the size of a Scrabble piece, so very small. They could be hidden in most places, do temperature, do humidity, do on and off, closed, open. So again, putting this into discrete places is quite useful, and again, it is the sensors and a gateway, and then they provide that service from their cloud into Azure. So just give me an example where the market's going. We have some bespoke built ones, which I mentioned before, around the lifts, but we can go into that a bit later on. And then we've got the digital twin. So this is what we've built the building provider on. Digital twins is in public preview. It's a service that's not been generally available from a Microsoft perspective, but we are working, one of 15 global partners that have been brought into digital twin service. So we're working very heavily. I think we're the only one in the UK to do this. We've pretty much built this now. 95% of that has been built and providing services into BI, into Power BI, and we're looking to have the app built into that as well. So this is where we see all kind of digital projects from a physical perspective being built in the future. You'll build a digital twin of a building, a car, another entity that you can build as a digital twin. That's just a digital representation of something that is physical. It's built in ontology, so basically you build from a tenant down to, let's say it's a building, a location, then a building, then it could be a floor, then it's a room, then it's a physical sensor or source you can add to that. So you can start to get reporting from a location perspective, or you can get it from a building perspective. So quite quickly you can see the granularity of actually getting the reporting being routed out through event hubs into an email alert when certain thresholds are being breached or certain conditions arise. And because they're all integrated, you can have things that you can start to look at correlation events as well to see what affects other things. So quite quickly, it's a great way. I mean, digital twins is not new, but having it in the cloud is especially new at the moment. So this is a better way of starting to leverage other services such as machine learning, AI, and start to integrate it into a digital building. So that's what the architecture looks like for that. So these are some knocked up visualizations, but the only reason I put these visualizations up is really to add some context around why air quality is quite important. We've heard it all in the news this week around some of the schools closing the roads, just to see what the impact on air quality and transportation has. So air quality there at the bottom right. Darren did these charts, so I'll hand them over to Darren to talk you through why we did these tests. So.
Yeah, exactly. So as Mark said, there's a school of thought that says there's an impact on a behaviour and performance with CO2. So we have sensors rolled out in the building here in Manchester. So we're measuring things like CO2, light, noise, occupancy, obviously, etc., temperature, humidity. And this is just a reading from one of the offices. So what we've got here is a sound pressure graph. So this is a day in one of the offices. So we can see there at 8 o'clock in the morning, somebody comes into the office, has a conversation, and then leaves, and then at 10 o'clock again, there's obviously a meeting of some description. So, various points during the day, the sound level goes up, indicating that somebody's in this particular meeting room. So in and of itself, not particularly interesting. However, if you start to overlay the CO2 levels within that room, then we start to see a different picture. And what we're seeing is that as soon as somebody comes into that room, the CO2 levels start to rise, but then they don't dissipate particularly quickly. And then as other people come into the room and use the room, the CO2 levels tend to rise and rise and rise and don't particularly fall off. And I think we're up to about 1,600 parts per million on this particular graph. And there have been studies conducted that show and demonstrate the impact on adverse levels of CO2 on cognitive functions. So from a basic activity perspective, a 35% reduction in performance, up to 2,500 parts per million. We were at 1,600 on the previous graph. The use of information, a 60% reduction, and then using initiative and those higher cognitive functions, a massive 91% reduction. So there is a demonstrable impact. on performance with CO2 levels, and we had no idea, literally no idea this was happening in our office. So, you know, we've taken steps to make sure that that room is more well ventilated, and that CO2 levels have dropped off. But again, you know, it's measuring what matters, and you know, having these sensors gives us a real good picture of what's going on in our own building. So on the visualization that I showed a few minutes ago, we had on the front of house screen, we had a number of parking spaces available. So we just thought it would be useful just to give you an insight as to how we've derived that. So we have a challenge here at A&S, as many of you I'm sure do, in terms of car parking. We have a number of staff in the building and only a certain number of car parking spaces, so it's a constant source of frustration trying to get your car parked in the morning. So IoT has a number of solutions for this, and some, you know, quite mature solutions of that. The first one being a bay sensor, so a bay level sensor which is physically mounted, surface mounted into the car park, which is usually an electromagnet where a car will roll over the sensor. That will signal to the cloud that space is being occupied, and then when the car rolls off again, a signal to the cloud to say that space is available, which is highly accurate. There's a high level of accuracy there, but the trade-off is cost, because obviously we need a sensor in every single bay, which can be quite costly. So another option there is entrance and exit counting sensors, so bump strips or cameras at the entrance and exit to a car park to physically count the number of cars that are coming in and out. And we took a slightly different approach here at A&S. So we thought we could use the power of the cloud and harness that to be able to actually see cars in the car park. So we have a camera in the rear of the car park, which we'll see in a second, which is actually looking at the car park and seeing cars. But in order for that to be useful, we need to train a model. We need to train a computer vision model to understand what a car looks like. So our first port of call was open source. So we used TensorFlow, OpenCV, and we figured out very quickly that it took an awfully long time to train the model, and over 160,000 pictures of cars, so cars parked, you know, irregularly, empty spaces, training this model to see, in inverted commas, what the car park looks like from an occupancy perspective. So we then moved on from that and started to work with Azure Custom Vision Service, which made things much more efficient. So instead of hours and days, it took minutes to train the model with far fewer images, with a prediction element to it, to enable us to predict occupancy, but also with the ability to be able to export that in other fashions. So what we came up with, it looks something like this. So this is actually what the computer vision model sees. So this is the shot of the rear of our car park. The green circles on here indicate the fact that those particular spaces are empty, and the percentage underneath is the degree of accuracy that the model thinks it's achieving. So every space is empty, and it thinks, you know, with 100% accuracy. So what we'll do is we've just got a little time-lapse video that hopefully will play, that will be able to show you the model working in real time. So as cars come in and out of the car park, we'll see that the circles start to turn red, and the model correctly identifies that those spaces are available, and then those spaces are occupied, and again with a high degree of accuracy as well. So this is the model working in real time. In order to be able to achieve that, if you think about how a camera sees a car park, obviously it takes a picture and transmits that somewhere. So the machine learning model needs to look at the picture and analyze the data. Two ways of doing that really. So you can do it in the cloud, so in the services and functions that we've talked about with IoT Hub, or there is a function called IoT Edge. So rather than sending a picture of the car park, or almost real-time video, up to the cloud for processing, it's much more efficient to be able to do that processing at the edge or on site next to the camera, and that's the deployment option that we've deployed. So we're using IoT Edge, which is basically a gateway-based infrastructure system that actually analyzes the pictures in real time and then makes a decision about each car parking space independently. So is that space available? Is it occupied? and then sends a 1 or a 0, depending on whether it's occupied or not, back to the cloud for processing. And we use Stream and SQL to be able to perform that function. With the output being that we can use, again, Power BI in this case, to be able to display that information. So we can see a visual representation of the car park here. We're pulling in weather data because we want to understand whether or not weather has an impact on whether or not we can, on how many cars are being parked in the car park. So do people leave the car at home? Do they travel in when it's bad weather? That kind of thing. We want to understand that. And then we can see on the right-hand side there the mobile version of the application as well. So again, taking a real-world problem for us here at A&S and turning that into a viable use case to be able to use IoT technology. The machine learning aspect, so taking that one stage further, once we have the data about the occupancy of the car park, we can then perform machine learning and analytics on that data to try and predict in the future what the utilisation of the car park is going to be. So taking in further feeds like people's holidays, calendars, to understand the occupancy and understand whether we're going to have any pinch points on that constrained resource in the future as well. So again, taking that one stage further and actually providing a prediction on occupancy using Azure machine learning. So another use case, Mark.
Yes, so we got engaged with Hovis. Hovis used to have 4 mills. They went down to 1 mill, 8 bakeries around the UK, and the silos are the large containers which hold the flour. And what they were finding is there was probably, post 100,000, so 6-figure issue each year with transportation turning up to a bakery to offload flour. The flour wasn't, there was no room in the silos because they weren't empty, and they were returning the flour. So it was a supply chain issue, and this particular issue didn't actually sit with IT. It sat with the process guys that look at efficient ways of driving down costs. So we looked at how they currently measured the silo depth, and that was a person with a piece of string and a tin can, and then measuring the depth of that particular silo. So we worked with Arrow to build a sensor that looked at infrared to look at the fill levels, and a level monitor as well, to then connect that via a gateway and 4G connection back into Azure, and then start to put that data into through Stream Analytics into Co2, into a database, and effectively we were using machine learning to look at the utilization stats, and also looking at how we would alert and provide feedback for the supply management people to start ordering. I mean, this was then just the avenue it took was that a person did this to start off with the view that actually they could place an integration into ERP, that when a certain level of silo hit the threshold, it will basically kick off a workflow to then kick off an order stream to the mill to then distribute that flour just in time, so they could start to really take advantage and cut down on this 6-figure, which obviously comes off their bottom line. So another use case, which is not necessarily it was the business outcome that they were looking to do, and they used technology to solve the problem. Of course, the guy that was doing the manual measurements now could be doing something a bit more proactive on the product line, and they're probably looking now to connect more of the product lines for building making the bread. It takes 3.5 hours to make 8,000 loaves of bread, and they're on the same batch, so the same load. And if anyone is over 118 grams, they scrap the whole lot of them. So again, they're starting to look at sensors. They are embedded. And it's a Siemens system, and basically the sensors fail all the time. But there's no way, unless you sat in front of the system itself, if you see the sensor or a humidity sensor fails. So they are looking at how they can make that product line a bit more efficient. So that's more of an industrial IoT solution, which obviously that market's been in place now, 30, 40 years. But still they can't drag that data out and look at what weather's like and how it affects humidity, things like that, and start making better decisions on the product line and with the silo fill status. And then this is Imperial College in London. So although this is a university who have massive problems with space utilisation and managing that utilisation, we are working with a large a large maintenance company that provides the maintenance for their 142 buildings in London, and the number one issue they have is lifts. So obviously they provide education services to disabled, and apparently students don't like to walk one floor to a lesson. So when lifts go down, it's the number one burning issue. So we worked, again, with Arrow to have a purpose-built sensor that had 6 sensor points or data points within a specific enclosure for them. It had a low-power WAN connection to a gateway, and we provided the backhaul services into Azure and started to build a preventative maintenance solution for them, so they could start to predict when a particular lift in the particular part of the building was likely to fail. So using machine analytics and that data model being built over a period of time, they could start to see the patterns of when things are likely to fail. So if, for instance, one of the use cases were that if the doors start to slow, then they can predict that, and they know likelihood that that is likely to fail. And now with the other data that they got over the period of time, they knew the length of time when that condition happened, when it was likely to break down. So now the uptime, now it's no longer a number one issue. Other general stuff like keeping toilets clean and things like that is their number one issue now, but this was their number one issue. Which shows you where technology can really solve some of these customer experience problems for large enterprises and establishments like a university. And so let's finish off really just by providing some considerations. If you're looking to engage in an IoT project, there probably, if you look into your business now, whether it's around space utilization, whether it's around operational efficiency, preventive maintenance, prescriptive maintenance, all them type of things within business, then you're likely to want to kick this off, and you want to be able to, I kind of referenced it before, around a centre of excellence, or having somebody own that sits between technology and sits between the business, that can horizontally fit across and act on everybody's behalf, but work and kind of own the centre of excellence kind of initiative, really. But as we've mentioned from the start, is all about the business outcome. What business outcomes are you looking to drive? It starts there, and the process that we go around and user stories and things like that is the best way of gathering the solution that will probably address that business outcome. And I kind of touched on the CEO, the Centre of Excellence before, so ensure it's supported by the business, it's supported horizontally. Make sure people understand that this entity is in place and there's somewhere for them to come, because most people will do this. We've all heard of shadow IT. There's a shadow IoT as well, so people will go out and do their own little projects when actually they could benefit a lot of the other entities within the business that you could get some benefits from an insights perspective. Ensure security is end-to-end, build it from the start. So if you're looking to build out an architecture, you can probably build out 80% of an architecture quite easily, and it can be deployed, it's repeatable, it's all that type of stuff that you want to do. It's only the use case at the end that changes, but you need to build security from the start, to making sure the sensor has the right security elements, both physical and from the software perspective, all the way through to data in motion and that data at rest, all needs to have security in mind. So that's pretty pivotal. So ecosystem partnerships are absolutely key. We found that 18 months we've been working on this, we've created some great partnerships, which from the left-hand side of the schematic, as we showed before, is pivotal, is making sure that we can build sensors, we can get sensors that will be pre-built to solve problems for customers. We have got a mechanism of engaging with somebody that can go and provide that particular solution. Then we will then back all that into the data, and that's where we got our strengths. We can provide the connectivity, we can provide all the data services within the cloud, and obviously we can build apps, integrate apps quite easily for customers. So for us, that ecosystem partnership, and you can look at anywhere, Gartner, IDC, all of them will say that ecosystem partnerships in this space are massive. So retrofit, so whether you've got a system that's already been deployed, you feel actually that doesn't provide with a certain level of data that I need, you can still retrofit. This technology is changing quickly. It's very technology we know is changing quickly, but the sensor manufacturers are changing and getting more up to date, more clever sensors that are coming out each week that can provide it. So you're likely to be changing this without having to rip a wall out to change out a sensor that's being fitted into the fabric of a building. So retrofit is fine, and there's sensors out there like Ocean's, another sensor manufacturer that is self-powered by heat and by motion. so power doesn't become an issue. So always start with an assessment, kick off the initiative, have the business outcomes, engage with a partner to go and do that, and ensure that you go through that process and understand, what is likely to be the business outcome, what we're trying to drive, which people are of interest within the business that should be engaged with, and when you start to look at getting all the data points, what data do I need, what data is important to me, how do I get that data out, can I get it out, and once you've got that data out, how do I then ingest that into the cloud, and then what insights are the most beneficial for different entities within your business. So executive might have one view, you might have operations and building management want another view, you might have visitors, you might have clients, you might have staff that all want to see different views that can all be built in this way. It all starts with that assessment. Power is obviously if you've got mobility with sensors moving around the building, the power is the most important thing. That's the main thing Darren touched on there. The sensors that get embedded into a car park, into a space, yes, very disruptive when you're installing them, but every 2 years you may have to rip them sensors up to replace the batteries. So that's the type of stuff that you've got to think about going forward. So you're looking at low power kind of connectivity mechanisms, which will connect these sensors, which will just do an on and off over a period of time, and then batteries last anything between 5 and 15 years. So quite important, from an operational administration perspective. And then evaluate your business, evaluate what resources you have that have the capability to be able to manage an IoT solution. So you're looking at data science. We have had data science, business analysts, you probably have them, architects, app dev people, cloud architects. They are kind of new age type. I know we've got some there that have been for a while, but they're turning into agile, turning into new digital services. The resources are very hard to find. We find it recruiting extremely difficult to get the right people to sort these type of workloads out and these approaches. So evaluate what you've got, and then plug up gaps you want to do, or you partner with somebody that can provide them services for you. So that's where we sit with that. So I hope that's some useful considerations for you if you're going on this journey. And what we'd like to do, really, myself and Darren, we'd like to thank you for giving up your time this afternoon and sitting with us and going through, and I hope it was useful. One thing I need to probably mention as well, so the next webinar, which probably will be it may be May, maybe June, which will be on a deep dive into digital twins as we've built this out for our customer to show you, the problems that we've had, but also what the wins and the benefits of doing that. So that's probably us.
I think so, yeah.
Q&A?
I don't think there's anything on the screen in terms of questions, but let's open the floor up, see if we've got any. If we've got any questions to come in.
I've opened everybody up. So has anybody got any questions we've discussed this afternoon? I mean, if you've got questions at a later stage, feel free to reach out to myself or Darren via our marketing department. We're happy to answer any questions that you've got. Certainly a lot of food for thought for you guys. A lot covered on this particular overview session. I think you got a good idea about the intricacies and the complexities that can be in a solution like that. But okay. Thank you very much.
Yeah, my case yesterday.
Thanks, guys. Great day.
Right. Genuinely.